You're very brave.
Got a notification saying this event is being live streamed. So okay, we haven't shown up yet apparently on the YouTube, but that seems like a good sign. Yeah, I see a little notification that says live on YouTube in the corner of my screen.
Nothing yet. I just see the
there might be a bit of a lag before it actually gets there.
One thing is, so it didn't give me an option to like connect that pre-created link that we already had set for the thing,
Yes.
But it does say it's live streaming. So if you just go to their channel in general, let me help out here. So I can be presentations quality.
Okay. Did you just refresh, Sean, or did you go to the? Okay, Sydney, I see. So the actual link that we sent out is not.
link goes to the defense of the web and other stories, but then you click the society.
Yeah, that's gonna be the issue, is that it's not gonna like the pre-created link. But let me.
I can find the link if I go to the upper left-hand corner of my screen. It says live on YouTube. If you click on that and then click on view stream on YouTube, it'll open up the YouTube video for this.
Okay. Okay. So I think then I don't suppose that Daniel Glure is here with us, is he?
Hey, Peter, can you just post a message on the YouTube page with the link that says go here for the live stream?
Okay, let me make sure I have the correct. So because I still am not seeing the right link. So where do I get the right link from?
I just
Sydney put it in chat.
Okay, yeah, actually that's right. Sydney can paste it. She's
Sean is on top of it. He is going to put the correct link into the chat on the YouTube original link. So anyone who goes there should be able to click on the correct link. Sebastian is also going to post it on Twitter.
Okay, great.
But the problem with those guys doing it is that, well, Sebastian's will be fine, but Sean's will go in the comments. Peter can actually make it so it looks like part of a title or something. So it's like, go here to watch this. So it'd be more easier to see.
Yeah.
Peter or Sydney, whoever.
Yeah.
Let's do that. And then once that is there, we'll wait to officially start, just so nobody misses the beginning of the talk. Thanks again, everyone, for your patience. We will get going in just a minute.
There is quite a bit of a delay between Zoom and YouTube.
Okay. Apparently there's a bit of a delay between the two. So whatever we're saying here is showing up probably a few seconds later on YouTube. That, and then once that is there, we'll wait to
yeah, and the delay is just something we can't really, it just, that's a permanent thing.
Again, everyone,
there'll be like a 20-second delay no matter what we do.
Marshall Hadeen apparently is enjoying this in offset stereo.
Apparently there's a bit of a delay between the two. So whatever we're saying here is showing up probably a few seconds later on YouTube. That, and then once that is there, we'll wait to
yeah, and the delay is just something we can't really, it just, that's a permanent thing. There'll be like a 20-second delay no matter what we do.
Hi everyone, I Dr. J. Dharmaraj from India. I'm working as an assistant professor in zoology, and I am also working on arachnology. First of all, I would like to thanks for giving this great opportunity to American Arachnology Society. So thank you everyone.
That's a permanent thing. There'll be like a 20-second delay.
Thanks everyone for being here. Yeah, it's really fabulous to have this online platform. Oh, now I can hear some of these. It's probably Peter dealing with the. Thank you, Peter. yeah, I just wanted to say again, thanks everyone for joining us. It's so cool that people are able to be at the American Arachnology meeting from all over the world. I think we have representatives from every continent except Antarctica joining us. So it's really cool to have so many people able to participate. The link has been updated on the website. Thank you so much, Daniel. And Peter or Sydney, can you let us know once the official link has been posted to YouTube so that anyone who joins us late over there will know where to go? I'm just going to wait on your, it's posted and pinned on the AAS Twitter, awesome. So the link that I've just posted, Rich, is the one that will work if you are trying to share with anyone who's not online. But the original link that was posted on the website or on Twitter, if anyone goes to that, they should be able to see the updated link in the comments. Can Sydney or Peter just give me a heads up once that's set up? And then we'll get going. And I'm going to record on my end just for a backup. But I believe that the live stream on YouTube should also automatically record. And then anyone who does miss it should be able to watch it on YouTube anytime after the fact. All right. I don't see Peter anymore. Sydney, are you there?
Yep, and I was just gonna send you a message that I don't see the old live stream that you had set up.
Okay.
So I don't know if it got taken down or if they just got rid of that one now.
Okay.
So I haven't gone and posted anything on it because I can't see it. So I was actually just waiting for Peter to respond there.
Okay. And I think that the correct link is now on the website. So if people go back to the original event page and click there, it should be updated with the one that is working now. Is that the original link, Sean?
No, the original link is still showing this.
Right. And are there comments? Yeah.
I commented.
Okay.
But
so
it disappeared though.
Okay, it's disappeared. Okay, so I think that no longer exists, but we are streaming. I think that the correct link is now on the website. Go back to the original event. Thank you, everyone, for your patience. Thank you, Jillian, for your patience with our dealing with this tech.
It was, I feel partly responsible for it.
No, it has nothing to do with you. We thought we had everything set up to go seamlessly. I think that we are kind of in the best situation that we can be at this point.
It's
It's
Just-
on the website now, the correct link. Sorry.
yeah, the first time out on these things is always kind of a little bit of a learning curve.
So if nobody stops me, I'm gonna get started.
Okay.
This is being recorded. At the very worst, we will have a recording of this that we'll post to YouTube immediately after the fact for anyone who misses it. And so I'm going to start by introducing Jillian briefly, and then we'll get going. So thank you everyone for being here. Welcome. Jillian Cowles is a clinical microbiologist, naturalist, and photographer joining us from Arizona. And she is the author of this truly wonderful book, Amazing Arachnids, which provides a window into the fascinating private lives, not only of spiders, but also all of the lesser known arachnid groups that can be found in North America, including the pseudoscorpions, vinegaroons, micro-whip scorpions, and short-tailed whip scorpions. And I first met Jillian in 2015 when she was a guest lecturer at the spider course held at the Southwestern Research Station in the Chiricahua Mountains in Arizona. And I was blown away by her presentation, her excellent work as a natural historian, and her gift for telling stories about the biology and behavior of arachnids through her photography. And I'm so excited that she's here with us today to share some of her work on Southwestern arachnids. And without further ado, I'd like to welcome Jillian to go ahead and tell us the tale of The Thief in the Web and other stories.
Okay, thank you very much, Catherine, for your very kind introduction. Okay, so let's get started right away. I'm trying to get my little cursor to work. Okay, allow me to introduce the thief, Argerodes Pluto. And this is a female. She's full of eggs, so she's really fat and sparkly. Here's the male. He's almost full grown, but even at maturity, they're only a few millimeters long. And there's probably a few reasons for that. One of the reasons is that they live as obligate kleptoparasites in the webs of black widows. In this case, it's Latrodectus hesperus, the Western black widow, who is far larger and more formidable than the tiny little thief spiders. So on rare occasion, exactly 2 times, in fact, over the years, I've seen Argerodes Pluto glean ignored prey in the webs of the black widows, small prey like this moth, where they feed on the prey and the black widow doesn't care. But far more often what you see is something like this. Here's 3 adult Argerodes Pluto living in a black widow web. They live as groups frequently. Here's an adult female, another adult female, and an adult male. This is a black widow egg sac. And if you look more closely at this male, you can see that he's actually feeding on a baby black widow. The baby black widows, when they're at this age, they're white. So when he was done feeding on that one, he went back for seconds. So what these Argerodes Pluto do is that they chew a little hole in the egg sac, or multiple holes. Here's another one. And they'll reach in with their chelicerae and they'll extract one baby black widow at a time and then feed on it. When he was done, the females each took turns. So here you can see a close-up of a female feeding on a baby black widow. So the problem for the Argerodes Pluto is how to get the egg sac from the black widow. Here's a black widow feeding on a grasshopper that she caught. This is in a natural area with just a rock wall to a wash. And she has a tubular silk retreat here where she incubates her current egg sac. This is a current egg sac. These are old ones where the babies had already emerged, and these ones have been discarded out of the silk tubular retreat. The black widow is extremely protective of her precious egg sac. So the problem for the Argerodes Pluto is going to be how to get the egg sac away from that black widow. And if any of you are familiar with J.R.R. Tolkien's Lord of the Rings, it's kind of like Bilbo Baggins trying to steal the Arkenstone away from Smaug the dragon, okay? These little thief spiders are going to have to sneak in and steal these precious egg sacs from the black widow. And what they do is they suspend them out in the periphery of the web. Here's 2 black widow egg sacs. They suspend them where they know that the black widow hardly ever goes. Here's 4 adult Argerodes Pluto living as a group in the web. A female here, a gravid female full of eggs here, another female down here, and a male here. So what they do, it's not so much of a who done it, but how do they do it? How did they steal that egg sac? So what they do is they wait for the black widow to wrap large prey well away from the entrance of her silk tunnel retreat. And if it's a small prey item, they don't spring into action. If it's too close to the silk tunnel retreat, they don't spring into action. But if she's wrapping large prey like this scarabaeid beetle out away from her silk retreat, then one of the Argerodes Pluto will zip up to the silk retreat as fast as they can go. They'll go inside that silk retreat, cut down the egg sac, and move it on out to the entrance. From the entrance, they manipulate it with their legs and by attaching silk off to one side of the entrance. And then they'll use a series of attaching silk and cutting the old lines and putting new lines and move it by increments away from that entranceway of the black widow. Now, most of the time, that's how they did it. But in one instance, I saw something really extraordinary. Instead of attaching the silk and moving the egg sac into some portion of the black widow web that the black widow rarely went to, instead what they did, what that Argerodes Pluto did that time was she pushed the egg sac out of the entrance, let it fall on the floor of the porch. She zipped down as if she knew exactly where to find it. She found it right away. And then she suspended it well below the black widow web. And this had all the appearance of planning. She seemed to know right where to find the egg sac, where it fell. And I'm wondering if she could have even been cheating in terms of not sharing the egg sac with others. Oddly enough, within 2 days, that particular individual was dead on the floor of the porch. I don't know why she died, but possibly being within the confines of the black widow web, it might provide some protection against some predators. And possibly by cheating, she may have been subjecting herself to greater predation risk. Get my little cursor. Here we go. Okay, so she moves it in increments, and you can see these light-colored objects in the background. Where she put it is close to her own egg sacs. These light-colored objects are Argerodes Pluto egg sacs, and she has already produced 3 egg sacs of her own during the time that she's been in this black widow web. So then she chewed a hole in the newly stolen egg sac and extracted these embryonic black widows one at a time and fed on them. After feeding on the egg sac for several days, about 10 days later, she was ready to produce an egg sac of her own. So she starts out with a little cup-shaped area of silk, which she tips on its side, and then she starts to extrude her own eggs into that cup. And you can see a deep dimple in the back of her abdomen as she's pressing out those eggs. And she did the entire laying of eggs within 1 to 2 minutes in a continuous process. At the end of the process, you can see that she has a volume of eggs is at least equal to her own volume after laying those eggs. So this is a tremendous investment on the part of the female spider when she produces an egg sac. She then covers the entire outside of the egg sac with silk, with a sort of flocculent silk. And then she builds a neck at the bottom. That's where the baby Argerodes will exit the egg sac. And then she puts layer upon layer upon layer upon layer of fine silk on the outside of the egg sac. And this is probably as protection against desiccation, because I live in a very dry climate where Sometimes the humidity is 10% or less. At the end of 4 hours, she's done building the egg sac and rests exhausted as she guards the egg sac. And you'll notice her 2 long front legs are stretched across that egg sac. And the reason why she guards it is because there's a little egg parasitoid wasp called Arachnoptermalis dazzes, which is intent on gaining access to that egg sac. And what she does is leg sweeps as she detects this wasp flying in the vicinity of the egg sac. And if the wasp lands on the egg sac, she actually chases it around, pursues it on the outside of the egg sac until she can catch it with her legs and then fling it. She'll actually fling the wasp away. She never seems to bite the wasp. I don't know why that is. Maybe the wasp doesn't taste good. I have no idea. At the end of about 40 minutes of watching this frantic little mother spider attempting to defend her egg sac, I collected the wasp, partly to get the wasp identified by an expert and partly out of pity for the little spider. So meanwhile, the second Argerodes Pluto female has been stealing an egg sac also from the black widow. So here's the second one doing that. And she's moving it out to the entrance. And then she's carrying it in increments away from there. Now you can see this bicycle tire in the background. All this was taking place on my front porch under a insect light that drew in certain, I mean, it was actually a bug light that was yellow that wasn't supposed to draw in insects, but it actually drew in a fair number of insects. And so the black widow was living in a really good spot, but this tire gives you some idea of scale. So as she's moving it away from the silk entryway, and you can see this entranceway on top of the tire here, that's the retreat of the black widow. You can see this little Argerodes moving it away. And one of the reasons why she has to get it away quickly is that the black widow, while wrapping prey, almost always would stop in the middle of wrapping and would rush back to her silk retreat. And I believe that she was checking on her egg sac when she would do that. She'd disappear for a little while. If the Argerodes had already stolen the egg sac, she would spend a long time in there, like 10 minutes before resuming wrapping prey out in the web. So the Argerodes Pluto seem to know right where to move so that the black widow isn't aware of them. But if the black widow happens to return to her retreat before the Argerodes is clear of there, in one instance, I saw an Argerodes bail out of the retreat very rapidly. In another instance, an Argerodes played dead. She just lay on the floor of the retreat and waited for the black widow to leave, to go wrap prey again. And then she simply stood up and disappeared into the retreat and came out with the egg sac. So the poor black widow does try to protect her egg sac, but these little Argerodes are very determined, and they seem to be very knowledgeable about where the black widow goes. And one of the reasons why I think that the black widow, why the Argerodes live as a group in the web, is that I think that the danger of stealing the egg sac is then divided among several different Argerodes. That would give a real advantage to having a group so that 3 females can divide up the risk between them. So as she's stealing this egg sac, you can see that this one has a black wasp on the outside of the egg sac. And this is Philolema latrodecti, which is an egg parasitoid wasp that specializes in primarily black widow eggs. So this wasp is competing for this resource with the Argerodes Pluto, and it's not alone either. There's Pseudogaurix signatus, which is an egg predator fly. What this fly does is lay its eggs on the outside of the black widow egg sac. Its maggots burrow through the silk, and then they devour the eggs of the black widow. So this little Argerodes Pluto is competing for this very valuable resource with at least a couple of other organisms. Out of 9 egg sacs produced by this particular black widow in the course of a full season. 1 egg sac was parasitized by wasps, 1 egg sac was parasitized by flies, 7 egg sacs were stolen by Argerodes Pluto, and of those 7, 1 of them was parasitized by wasps, and the Pluto discarded that after stealing it. Okay, by morning, the little Argerodes Pluto has moved her egg sac this far along. You can see the bicycle tire. This was the silk retreat of the black widow up here. And then she proceeds to chew a hole in the egg sac and feed on these very embryonic black widows. Now you'll notice that in this photo, an Argerodes Pluto is actually feeding on a baby black widow as another one is exiting the egg sac. And by chewing only small holes in the egg sac, the development of the remaining black widows in that egg sac is not compromised. So baby black widows are able to emerge successfully from the egg sac, even though the egg sac has been fed on for several days by Argerodes Pluto. In one case, I counted over 70 baby black widows that successfully emerged from the egg sac despite the Argerodes Pluto feeding from them. When they do emerge from the egg sac, they hit the web running. They very rapidly disperse from the maternal web. And I did see an Argerodes Pluto briefly pursue some baby black widows as they were emerging. And the baby black widows had no problem outrunning the Argerodes Pluto. But all of these black widows dispersed completely away from the maternal web within 2 hours. I call this precocious dispersal because I've never seen any other baby spiders emerge from an egg sac and disperse that rapidly. I think it might have evolved in response to the presence of these little predators in the web of the black widow. Now, one of the really good questions that comes up, and this is where the twist in the story comes along, is what's in it for the black widow? Because this is a very obvious negative selective pressure on the reproductive success of the black widow. Even though 70 babies emerged from 1 egg sac, in many cases, no babies emerged. So, and just the fact that these Argerodes Pluto were able to steal 7 out of 9 egg sacs, that's a very significant negative effect on the success of the black widow. So why on earth would the black widow be tolerant of these kleptoparasitic spiders in her web? Well, what comes to mind is the old joke about hiking in grizzly bear country. The story goes, if you want to hike safely in grizzly bear country, make sure your hiking partner runs a whole lot slower than you do, because then all you have to do is outrun your hiking partner. You don't have to outrun the bear. Well, here's the grizzly. This is Mimetis, a pirate spider. I removed 7 pirate spiders from the web of 1 black widow over the course of the field season. And these pirate spiders preferentially prey on orb weavers and comb-footed spiders. And both black widows and Argerodes Pluto belong to the Theridiidae, which are comb-footed spiders. My little theory, my hypothesis, is that the black widow might benefit because the low-hanging fruit, the Argerodes Pluto, might serve to be prey for these Mimetis spiders and might spare the host. They're easy, they would be very easy to pick off, they're accessible, and that might be the selective advantage to tolerating these little kleptoparasites in the web. The next part of the story will maybe reinforce this, but this is a hypothesis. It would have to be confirmed by further observation. So another comb-footed spider in our desert Southwest is Ptideron sisophoides. It's a distant cousin of the black widow. And instead of silk tubular retreats, what they do is they fasten together cottonwood leaves or some other leaves. In this case, they almost are always found in riparian areas where there's cottonwood trees. So sometimes they'll curl one leaf around as a retreat. And if you were to twist that same leaf around, you'd see the spider with an egg sac in that leaf retreat. So in the Tadaran webs, what I was finding are Neospintharis bavokivri. So that's a female spider at rest. She looks like detritus in the web, and an egg sac of the Neospintharis. There were many, many of these Neospintharis group living in Tadaran webs, sometimes over 30 of them in a single Tadaran web. Now, previously, Neospintharis had been documented as a predator on Philippanella, which is a non-venomous small spider in the Uloboridae. But when they're present in Philippanella webs, they're usually solitary araneophages. They are preying upon the little Uloborid spiders. In the Tadaran webs, they're group living, and primarily they live as gleaning prey. Now they're highly variable in color. Here's one female, here's another female, and here's a male. And one of the reasons why I wanted to show a picture of this male is that you'll notice he has 2 long legs on the far side of his body, but on the near side of his body, those 2 long legs are left and he only has stumps left. And just file that away for future reference. So as I mentioned, I think that these Neospintharis were primarily living as gleaning small ignored prey in this web because it was in a riparian area with lots of little ants and gnats and other abundant prey in the web. So they could get small prey that the Tadaran seemed to ignore. Also, trundling around on the outside of a leaf shelter of a Tadaran was Philolema, our old friend that is a wasp egg parasitoid. So maybe they also use Tadaran eggs, but that would have to be confirmed. And you'll notice this small spindle-shaped object next to this fully alive Tadaran. Well, I collected some of these little cocoons, and what emerged were Zatipota. Now, these Zatipota wasps are ichneummonid wasps, and what they do is they are external parasitoids of comb-footed spiders. That's primarily what they are anyway. And you can see this wasp larva that is feeding on the blood of this little theridiid spider. And when it's ready to pupate, it kills the spider and then spins a cocoon out in the web of the spider. So the presence of the cocoons next to alive Tadaran hosts is fairly strong circumstantial evidence that the Zatipoda were using the Neospintharis as their hosts. So once again, maybe the presence of the Neospintharis were providing a host for the Zatipoda that might be protective of the Tadaran, analogous to the presence of Argerodes being protective of the host Black Widow when Mimetis was around. Okay, so Black Widow webs were also interspersed in between the Tadaran webs in the same riparian area. And you can see this cottonwood leaf with the bent stem, use that as reference. So the next photo, there's the cottonwood leaf with the bent stem. And in the foreground, just in the focus ahead of that, these little white arrows are pointing to 5 Neospintharis that were living in the Black Widow web also. There were more than that, including an adult female Neospintharis with an egg sac. And also present in the web was a lone Argerodes Pluto guarding an egg sac, but you notice she is missing her 2 long front legs. She's only got 6 legs left. And I only saw legs missing if Neospintharis were also present in the web. So I think that there was aggressive interactions between the Neospintharis and the Argerodes Pluto, very likely. So in a single Black Widow web, you could have the host Black Widow, 1 or more Argerodes Pluto, 1 or more Neospintharis bavokivri, Philolema, Pseudogaurix, Arachnoptera malis, Zatipota, and possibly Mimetis. So my main point is that these are very complex systems, and to really understand how the different players interact, you really need to look at it in a natural setting where there's lots of ability to see everybody, all the players. Okay, let's go to a much more simple puzzle, and this is in regard to Greenling spiders. Now there's many Greenling spiders throughout the tropics and subtropics, but in Arizona we have Pucetia viridans and Pucetia longipalpus. Now these spiders do protect their egg sacs, and here's a female spider feeding on a katydid close to an egg sac where the babies have emerged. But the babies hang around for several days after they emerge, and then they go through a molt, and then they balloon away. The presence of the mother, though, is very important for the success of the egg sac. In one experiment, I think that when they removed the mother spider, the success of the egg sac dropped from like 70% to 10%. So predators will go after these egg sacs if the mother is not present. And the predators could be ants, beetles, grasshoppers, and possibly vertebrate predators such as rodents or birds. So back in 1946, the Bulletin of the U.S. Army Medical Department published a paper by a guy named Captain Ernest R. Tinkham called A Poison Squirting Spider. And in this paper, Tinkham described how a serviceman was kneeling behind his motorcycle, and he was trying to adjust something with the tail lens of the motorcycle, and he was reaching with his screwdriver when all of a sudden he felt something like hot lead squirted into one of his eyes. And he couldn't see out of his eye, so he went for medical care. And later on they investigated and they found a Greenling spider with an egg sac behind the license plate on the motorcycle. So this went under the radar for about 40 years until Linda Fink published in the Journal of Arachnology in 1984 a paper called Venom Spitting by the Greenling Pucetia viridans. And she described how before spitting, a female shifts her weight posteriorly, lunging slightly forward immediately before or during the release of venom. So anyway, I included this observation in my book, Amazing Arachnids. And Rainer Felix in Switzerland read that, and he contacted me and he said, you know, there's just one problem. The hole in the fang faces the wrong way. So how do they do that? So we set out to investigate. I sent Rainer some specimens so that he could do the scanning electron microscopy on the fangs. And sure enough, the fangs, the hole is facing the wrong way. It's close to the tip of the fang, but it's facing the wrong way. So we set out to investigate. So these Pucetia viridans primarily like building their egg sacs in cholla cactus. And so you can imagine trying to test spiders that are guarding egg sacs in the middle of these cholla cacti. And what we did was my spouse and I, Bill Savory and I, got some glass cut into 4-inch by 6-inch pieces. We wrapped tape around the glass, and we printed up a picture of owl eyes to hold behind the glass. And then we approached the spiders that were guarding egg sacs in the cholla. And sure enough, we got spray on the glass. You can see one drop here that was from one fang, and here's a spray pattern from the other fang. So I contacted Rainer and I said, well, they sure can spray. And he said, well, we still need to find out how. So I went back and I tried to photograph them spraying. And this will give you an idea how they do it. You'll notice that the bottom of the spider at this point where she's first locking in on the target, which is a threat, it's going to be black tip forceps approaching her. But you'll notice that this is basically a straight line on the bottom of her body there. And then as the forceps approach, here's the tips of these black plastic tip forceps. What she does is she tips her cephalothorax upwards so that it's no longer in a straight line. She extends her chelicerae forwards, and then she was able to spray. And you'll notice also they spread apart their chelicerae rather widely as they're spraying. So in this case, you can see droplets of venom on the tips of this black plastic forceps. And you can actually see one droplet left on one fang and the other fang is still squirting. In this case, the spider was actually trying to pull away. You can see the forceps aren't even locked onto her legs. She's just moving very fast though. The legs are kind of a blur, but you can see she overshot. Here's her line of venom spraying. And this one is really nice because you can see the forceps directly in front of the spider. She's facing it. Here's the tips of her fangs right here. And then she tips her cephalothorax upwards and extends those fangs, and she's able to spray something that was right directly in front of her. Here's the spray lines. Of course, if they need to spray downwards, they can also do that. So that was a neat little puzzle and a lot of fun, and it really showed how someone who has a critical thinking mind like Rainer Felix was able to get us started on a really fun little project. So the next thing you might wonder is, well, is it only spiders that show extended maternal care of young? And no, also vinegaroons do that. So, trying to see my little arrow here. So I investigated vinegaroon maternal care of young by building a cutaway burrow out of clay that I could put up against the terrarium, and then I could observe at home. So one of the things I wanted to emphasize is that all these studies I've been doing are either at home or on my porch or just basically in areas within easy driving distance. So here's the cutaway burrow. This is a month after these babies have molted. They actually spend a whole month in the burrow after they molt. And they're proto-nymphs at this point. And the mother vinegaroon had gone up on the surface, had captured a large cricket, and it brought it down and actually deposited it. And the babies started to swarm on the cricket, and she just stood back and let them have it. Even after emerging from the burrow, the mother vinegaroon shared food with her babies. In this case, this mother hadn't fed for 7 months, and she was really famished, but she's sharing her very first meal with this baby vinegaroon, which is reaching between her pedipalps and getting some of this pre-digested cricket mash from the mother. And sometimes several babies will swarm around the mother, pulling off chunks of the masticated cricket. Here's a baby here, several other babies around, and here's a number of them swarming around the mother. So one of the things that was really startling though was this case, and I was so unprepared. So there's water drops on the glass. I really wasn't prepared for this at all. I continued feeding the vinegaroons that I had kept even after the babies emerged from the maternal burrow and had made their own little burrows. And the mother was present in the terrarium. And so every week I drop a bunch of crickets in the terrarium, little crickets for the babies, big cricket for the mom. The mom in this case captured a very large cricket, but instead of going into her own burrow, she turned in the opposite direction, headed over to one of the babies' burrows. She reached her antenniform feelers down into the baby's burrow, and the little baby popped up out of the burrow. They proceeded to tap each other with their antenniform feelers over a period of several minutes. Then the little baby latched onto the drumstick of the cricket. She turned around, she headed into her own burrow. And in the morning, I saw the baby on the ceiling of the maternal burrow. The mother vinegaroon was there and the cricket was gone. And she had clearly shared the food with the baby. Now, what was extraordinary to me is that she, first of all, the way that she deliberately went to the baby's burrow instead of immediately heading into her own burrow. And the other thing that was extraordinary is that this occurred in November and the babies had emerged in July. This was a full 4 months after the babies had emerged. This is what I really call extended maternal care of young. So this last little project that I'm going to talk about is UV fluorescence and reflectance. And this is really a very preliminary little study that I've just started, basically. But I thought it might be sort of fun for eye candy and to give people an idea of doing their own testing. So everybody knows that scorpions are fluorescent when you shine a UV light on them. And when they have their babies, the babies when they're first born are not fluorescent, so they'll look dark. And then when they molt, you can see the exuvia here. After they molt, the babies are fluorescent. So everybody knew about that. The old UV lights basically only picked out fluorescence in scorpions, but in no other arachnids that I know of. The newer UV lights are really cool though. And you'll see that with the newer UV light, you can see that the solifuge is very brightly fluorescent. And even these smaller ones are really brightly fluorescent. When these things are moving around, zipping around, they look like blue streaks, literally, using a UV light for a source of light. And most arachnids show this sort of what I call intrinsic fluorescence. So this is a good example. This is a selenopid crab spider on the wall of my house. And on that same wall, which looked white under natural light and black under UV light, you'll see that the eyes and the leg joints show fluorescence. And this blue fluorescence, I believe, is due to the blood of the arachnid being naturally fluorescent. Hemocyanin has this blue fluorescence. And so basically all arachnids are somewhat fluorescent. If you were to grind these up and test them in a test tube, they'd all have some fluorescence because of this. So the thin areas of the cuticle show this blue fluorescence. Here's amblypygid, and you can see the eyes and the leg joints. Interestingly, when amblypygids have babies, opposite from the scorpions, the babies are fluorescent when they're first come out of the egg. Thin areas of the cuticle, like on this trapdoor spider, this Antiquities, also might show through the fluorescence. And when he raises up his legs in a threat display, you can see how those joints, those thin areas really pop out with this blue fluorescence. And even little newborn Aphonopelma show a kind of neat fluorescence of the abdomen. But a different kind of UV, what I believe is reflectance, is seen in animals that are exposed to the sun a lot. For example, Argeope, that is an orb weaver, shows this really neat reflectance. I believe that this is mainly reflectance. Agelonopsis, Calolena, so these sheet web weavers that might spend some time out where they're exposed to the sun seem to have reflectance. Even the lycosids have a little bit, not a lot, but some. And things like these sporacid spiders look pretty strongly reflectant. Harvestmen, the ones that are in low-level desert, show some of this reflectance. But you can see the thin area of the cuticle, a deeper blue color, and I think that that's from the hemocyanin, possibly fluorescence. I think that this is mainly reflectance, this whitish look, and that this might be fluorescence here. And the harvestmen at higher elevations don't need so much. So that was Dalquestia from Oak Zone. Now the crab spiders are really instructive because this is Misumenoides formosipes, which is an ambush hunter that's out in exposed areas right on flowers frequently. So here it is on the flower that was captured on with UV reflectance primarily. Okay, so I think that this is mostly reflectance going on, which might be protective against damaging UV. But the crab spiders that live in foliage, like this one that I find in mesquite trees, are very strongly fluorescent. So this is real fluorescence where they glow. This is Cynema viridans. The first one was Mecaphasa. Here's Cynema viridans, which also occurs in Arizona, by the way. And this was right from my yard. And Mesomesis, also very, very fluorescent. Whereas Tamaris, which is also in that same family of crab spiders, is more, it doesn't go so much in the foliage as along little twigs, and it seems to primarily capture ants, and it has very little fluorescence. Just mainly these thin areas of the cuticle where I think that the hemolymph shines through. Fuchsia viridans, I find that in foliage a lot, and it's pretty fluorescent. And interestingly enough, this particular philodromid is very brightly fluorescent, but most philodromids that I tested were not. This one I find in oak foliage, and I think it might be diurnal, whereas most of the philodromids I see are, I think, nocturnal. So that might be of interest. And even this Uliboris has some bright fluorescence, and I found those in oaks, Quercus rugosus. The salticids have a really interesting pattern. This is Bellota, an undescribed species of Bellota found in Arizona. And look at the bright UV fluorescence. And these are the ones that really got me thinking, because this is Metaphytopus chyra. It's a very tiny juvenile. And these juvenile salticids that live in foliage have incredibly bright fluorescence of their abdomen and their pedipalps. And the Salticus papalis juvenile has really bright fluorescence of the pedipalps. So what I'm thinking is maybe the fluorescence might be used as a lure to like flies. I mean, that's really, really strange looking to have such brightly fluorescent pedipalps. And it's only in the juveniles that I see these bright fluorescence. And Nerine, a linyphiid that hangs under webs, has also really bright fluorescence, actual UV fluorescence with a bright apple green. So I want to just finish up by saying that exploring and doing research is tremendously fun. I would strongly suggest that people just start checking things out. But us amateurs would love to have a venue for publishing our findings that would be friendly to amateurs. I think that would be tremendously helpful if professionals had an easy way to access amateur observations that were published in some easily accessible venue. I hope that someday iNaturalist could do something like that. Maybe if a lot of people ask for it, maybe it could happen. So I'd like to finish with thank you very much for having me. I'm sorry that we ran a little late. And I hope that there's time for a few questions.
Thank you so much, Jillian. That was fantastic. Everyone has been saying, wow, how amazing all of your photographs are in the comments, and that they didn't want the presentation.
Oh, Catherine, I can't hear you.
Sorry about that. Yeah, I got muted somehow. That was amazing. Thank you so much for sharing your work with us. And we definitely have some time for questions. And I think, Sebastian, if you're around, I want to start by asking some of the questions from the live stream on YouTube.
Copy them down.
Okay, I can hear you, by the way. So
perfect. Okay.
Sorry about that.
Sebastian, are you there? Okay, I can ask them because I have a copy of them here. Never mind. So I think this was back with the Black Widows, which, oh my gosh, what an amazing story, and how many players are involved in that one web. That was so cool. The question is, do you have an idea about how this kleptoparasitic lifestyle evolved from a more standard predatory lifestyle, maybe? I assume of the Argerodes and the other guys living on the web.
I'm not sure how they evolved, but I think that the small size is partly an advantage because of rapid maturation. So you don't know whether they developed small size and were able to move into webs because they needed to mature rapidly, and that selected for small size, and then they were able to move into webs. I have no idea actually how that might have worked. Some people hypothesize that these kleptoparasites got into the host webs because they imitate baby spiders. Well, unfortunately, I don't buy that, and I'll tell you why. Because in most host webs, the host is not terribly maternal about their young. For example, the big orb weavers are usually not even alive at the point where their babies emerge. And the black widows are definitely not, at least the black widows here are not social in any regard. So I don't think that it's imitating baby spiders. I think that there was something else that drove them to evolve that was a selective advantage for small size, which probably also was advantageous for them being able to live in webs. The small size may allow them to mature rapidly, but they couldn't catch big prey by themselves. So that's my thoughts on it.
Thank you. And there was another question, is the black widow able to do anything to defend against the parasitoid wasps and flies, or is the egg sac checking behavior specific to the Argerodes?
I only saw it specific to Argerodes. Basically, whenever she wrapped large prey away from her retreat, she would rush back at least once during that time and check her retreat, which I think was for the egg sac. I did see the black widow discard. One of the only egg sacs that the Argerodes did not steal was an egg sac that the black widow discarded, and 2 days after she discarded it, the flies emerged from it. So the black widow seemed to detect that there was something wrong, and interestingly enough, the Argerodes did not steal that particular egg sac. They did steal an egg sac that was already infested with the little wasps, though. So I don't know how discriminating they can be. But it was very interesting that a fly-infested egg sac was not stolen by the Argerodes, and the black widow ended up discarding it herself before the flies emerged.
Cool. And so while we're on the topic, Daryl Ubik wanted to know what's the Latrodectus survival rate from egg sacs parasitized by the flies or wasps compared to that from Argerodes?
I don't know, because I have a very small data set. Of the egg sacs that I saw go to completion, I really only was observing a couple big black widows in my yard itself where I could see it go all the way to completion. And out of I think it was 12 egg sacs that I observed, 7 of them were stolen by Argerodes that were on the porch one. And of those, 1 of them had been infested by wasps already, so that leaves 6. Of those 6 egg sacs that the Argerodes stole, I think that like 4 of them had baby black widows successfully emerge, but sometimes in lower numbers than the 70 that I counted the one time. Sometimes the baby black widows emerged when I wasn't there. So I just see, oh, the egg sac's empty now and been discarded, you know? So I have no idea what the actual success rate was.
And another question about the black widows is from Alexis Dodson. Do you think that the small hole, in addition to limiting food output to manageable levels, so the hole in the egg sac, makes sure that her food source stays developing so that they're alive and healthy for when she next takes a snack?
Yes, I think it's partly to preserve the lives. Well, it works both, it's beneficial in several ways. First of all, it keeps them viable so that they can be fed on over a period of time, yes. But also by allowing some of them to actually emerge and disperse, that guarantees a source of future black widows for future Argerodes. So I think it may be a case of co-evolution going on where the parasite, the Argerodes is the parasite, and it has fine-tuned its impact on the black widow so that it doesn't completely, you know, it's not completely lethal It's in fact, I never saw Argerodes feeding on a black widow. Now, I'm not saying that they never would, but in the case of an adult black widow, that is, but they seem to be very preferentially picking off these egg sacs and not attacking the host spider. That would be like killing the goose that lays the golden eggs, right? So, so I think that this is a sign of coevolution occurring. The response of those baby black widows immediately dispersing from the web, and the fact that the adult black widow seems tolerant of these is very suggestive of coevolution, in my opinion. That the host and the kleptoparasite have a very close relationship, and in fact, these Argerodes Pluto are obligate kleptoparasites in black widow webs, which to me is also very suggestive that there's been a period of coevolution going on.
So cool. And so on that note, on the other side, how do you think the baby black widows detect the presence of the Argerodes and know to run away? Like I've observed black widows, the babies tend to stick around on the web. So it's incredible that they just immediately run off.
The Western ones, I'll tell you, I've had black widow egg sacs in the house, and when those babies emerge, they're dispersed through the house usually. So I think it's the presence of the Argerodes, that they have, you know, the ones that hang around in where Argerodes Pluto are present. If the baby black widows hang around, they probably become lunch, you know? So, so I think that there's probably been a very strong selective pressure that where Argerodes have evolved along with the Western black widows. I think that rapid dispersal has probably been strongly selected for.
Awesome, thank you. There's a lot of questions. Everyone is super interested in all of the aspects of your talk. I think moving on to the Oxyopes or the Oxyopid. So Paula Cushing says the spray looked really viscous. Is it only venom, or is it like Scytodes where they combine glue or some other substance?
We think it is venom because of the fact that the guy that got it in his eye, you know, had such severe pain. And so it probably has some proteolytic stuff in there and caused some pretty significant pain. But to be honest with you, nobody's done an analysis of it. So that's a good question. I have a lot of questions about the Oxyopes. For example, is it only Pucetia that can spray? You know, do any of the other lynx spiders spray? Most of them are very tiny, so I don't know if they would. How well does Pucetia aim? You know, do they have a preference for aiming at something that looks like an eye? In one case, the drop went right smack over one of the owl's eyes, you know, the owl picture eyes that I was holding. But these are all things that have been not tested. So they need to be tested a lot more.
I loved that experiment with showing them the picture of the owl. That was super clever. We have some questions about the baby vinegaroons. So someone on YouTube wanted to ask, do the mothers perform trophallaxis, or are they like pre-digesting the food for the offspring?
Okay, so arachnids pre-digest their food as they're masticating it. They introduce digestive enzymes, and then they suck down the pre-digested liquefied food. Most arachnids do. Some mites eat whole, you know, chunks of food, and so do some harvestmen. But most arachnids do the pre-digested thing. So these babies, I think, are simply grabbing chunks of this kind of cricket mush, and then they probably suck down the liquefied food. I never saw trophallaxis in the sense of regurgitation. I never observed that.
Thank you. And Sebastian would like to know, it was so incredible how you were able to record the maternal care, and what sort of care substrate feeding worked for you? How did you manage to keep them in captivity?
Okay, I had to build a cutaway burrow out of it was regular clay that you would use for making pottery. And I had to get that clay fired. The clay was a maternal burrow with a clay tunnel retreat attached. And I set up a 10-gallon tank with this burrow up against the glass. And then I put black construction paper across the front of the glass so that during the day, the vinegaroon had complete privacy and felt secure in that artificial burrow. It's important to use clay or plaster of Paris, something that doesn't mold, but also allows water to seep through and penetrate, because every day I had to humidify that substrate, or else the babies would become very thirsty, and you'd see them hanging from the ceiling with their tails hanging down. They were desperately trying to get moisture from the ceiling of their burrow if it got too dry. So you have to give a material that moisture can sort of seep through, and that they can get the moisture from condensation on the glass and other things. So basically you have to just set up a really good terrarium with a cutaway burrow that's made out of the right material, and then just observe and make sure that the female is well fed and has had a chance to mate the fall before. And that's about it.
Awesome. And everyone was oohing and awing about the photographs of the reflecting arachnids, and several people wanted to ask what kind of UV light source you use, if you have recommendations, and if you know what the wavelength is.
I meant to show that. Can you guys see me okay? Okay, so this is the little UV light nowadays. They're not the big fat mag lights that used to be used. Do a search online, and there are people that supply these little lights. They have a lower wavelength than the old mag lights do. The old mag lights had close to 400 nanometer wavelength. These are closer to 360 nanometers. So slightly shorter the wavelength, and they also have a filter on the end that filters out almost all the regular visible light. And they're very strong, so do not look at these lights, directly. You could damage your eyes, but they are great. I can pop out a baby Metaphytopus chyra from like 6 feet away with one of these mag lights. They pop out, they are incredibly fluorescent. The Megaphasa crab spiders, same thing. You can spot them from feet away at night in the foliage. And you might say, well, during the day, the regular light sort of dilutes out the UV light. How on earth could that ever be of any value to a predator trying to lure in a fly? But I'll tell you what, the reason why I started testing these things is that I was beach sheet hunting, and a white Megaphasa crab spider fell on the beach sheet. And before I tossed it back into the tree, I looked at it in the sun, and it kind of had a hint of a glow to it. And I thought, I wonder if this thing is fluorescent. And I tested it with a new light, and it popped out so hard. So this little bit of a glow might be visible even in sunlight,
Thank you. And some folks are wondering that specific flashlight that you were holding up, do you know the brand, the model?
I don't, well, this particular brand is called Convoy, and I got it at the Gem and Mineral Show in Tucson, but I don't know if he's got this available all the time online. But if you do a search online for UV fluorescence, there's photos of some lights that you can purchase that are just like this. And it'll show, like, they'll give examples of solifuges and things like that that are fluorescent. So
yeah, and you said it was about 360 was the
somewhere around 360 nanometers, I believe, is the wavelength. Get one somewhere in that ballpark. Yeah.
Okay. Oh, awesome. Brian found a link on Amazon to a Convoy flashlight filter. So it looks like that's the one. Thank you, Brian.
Yeah, they're really fun. You'll be so
yeah, everyone's going to want to go out and start seeing which arachnids glow. Marshall Hadeen says, Jillian, your observational skills are simply spectacular. And I want to echo that. It's so incredible, the detail that you've managed to capture. He asks, can you please comment on how you have developed your skills?
Primarily because I was doing photography. And, you know, if you get a macro lens and you start doing more photography, it really pushes you to develop your observational skills. And the more that you photograph, the more that you get questions about stuff. And it just is like a positive feedback loop. Basically, the more you document, the more you see, the more questions you have, the harder you try to get more documentation. So I would say that doing research and discovering things and seeing things that might be seen for the first time ever is probably the most thrilling thing that you can go through. I mean, it's really addictive. It's like a terrible drug, you know. and once you have a taste of it, you'll never want to stop, you know. But I do wish that there was a way that amateurs could share what they're seeing more easily. You know, we need some venue that we can share stuff. This fluorescence stuff is so preliminary. It's all hypothesis right now. There's no hard data to support any of the hypothesis other than I see some patterns to UV reflectance and fluorescence. Wouldn't it be great though if people could use this as a jumping off point for their own graduate studies, you know? I mean, it would be such a nice interaction between professionals and amateurs if amateurs could just throw some stuff out there and then the professionals could run with the ball and get some of the really rigorous studies done.
Yeah, and a lot of folks have been saying how impressed they are by your work and what the line between amateur and professional is quite blurry. And also some folks from the AAS are saying that they encourage people to publish natural history observations in the AAS newsletter. So they welcome articles there. And yeah, thank you, Jillian, so much for sharing this with us. It was an incredible presentation. It was really inspiring. Yeah, inspires me to want to go out and look more closely at the arachnids in my backyard, because yeah, there's so much going on. It's really wonderful.
And thank you so much for having me. I really love to share this stuff, and I hope that people will feel how much fun it is. It should be fun, you know. It shouldn't be a job. It should be fun.
Absolutely. Yeah. Thank you everyone for being here with us. And I think, yeah, please feel free to continue to post comments on the YouTube video that we were recording this session. So we'll have it up. It'll be on YouTube forever if you want to go back and watch it again, look at the amazing photographs again. And thank you, Jillian. Thank you everyone for being here. I would like to remind everyone that there are poster sessions this afternoon, so please check out the posters. There will be individual Zoom rooms for each poster presenter where you can hang out and ask them questions. We're also going to have a casual night tonight. So if you have photographs, people will be sharing things from their own work and backyards and stuff like that. So come to the casual night and hang out. And sorry, that's my dog barking in the background. And yeah, this meeting has been so fun so far, and looking forward to another 3